Hello everyone. In this video lecture, we will see how to examine the stability of a given characteristic equation using Routh's array, right? So my characteristic equation is s to the power 3 plus 5s to the power 2 plus 10s plus 3 is equal to 0. Now, according to the Routh stability criteria, we will arrange the coefficient in an array which is called the Routh's array. So for that, we will first write down the s value from the higher order to s to the power 0, right? So my first value will be s to the power 3. So because the highest power here is 3, then we can write s to the power 2. Then we will write s to the power 1, and finally we will write s to the power 0. So s to the power 0 is the lowest value in s. Now what we will do is that we will arrange the coefficient in this Routh's array, right? So we can see what is the coefficient of s to the power 3. Here the coefficient of s to the power 3 is 1. So I'll write here 1. Now next we will see what is the coefficient of s to the power 1, because we have to put the coefficient of odd powers only because it is started from the odd power, right? So next odd power is s to the power 1 and the coefficient is 10. So after that I don't have any odd power of s, so we will stop here. Next we will see what is the coefficient of s to the power 2. So we can see here the coefficient of s to the power 2 is 5. So I'll write 5 here. After that we can see next even power is s to the power 0 and coefficient is 3. So I can write here 3. So this is all about the first two rows of Routh's array. Next we have to fill the s to the power 1 and s to the power 0 array. For that we have to perform some calculations, and the calculations will be this particular value, let this particular value is let a1. So what will be the value of a1? So a1 value can be calculated as a1 is equal to 5 into 10 minus 3 into 1 upon 5. So this will be 50 minus 3 upon 5, which is equal to 47 upon 5, and the value is 9.4. So a1 value is 9.4. Next we will find out the value of a3 let. So let us find out the value a3, right? So we know that these particular values are 0 in these two arrays. So s3 can be calculated as 5 into 0 minus 0 into 1 upon 5. So a3 will be equal to 5 into 0 minus 1 into 0 upon 5, and the result is 0. So this particular value is 0. So this is how we can find out the value of s1 rows, right? Okay, let us fill up the s to the power 0 rows. So for that what we will do, let this value is b0. So b0 coefficient can be calculated as b0 is equal to 9.4 into 3 minus 0 into 5 divided by 9.4. So this is 9.4 into 3 minus 0 into 5 divided by 9.4, and the result is 3. So this coefficient is equal to 3. So I don't have any other s value. For that we need to calculate the coefficients. So this is all about Routh's array. So we have completely filled up the Routh's array with all the coefficients. Let us see how to examine the stability of this particular characteristic equation, right? So the necessary and sufficient condition for stability according to the Routh's stability criterion is the first column must have the same sign. As you can see, this first coefficient has a positive sign, this one has a positive sign, this is also positive, this is also positive. So all the coefficients in the first column are of positive sign, right? So from here we can conclude that this particular system is completely stable, right, as there is no change of sign. So in the next lecture we will see a few examples of instability, and we will understand about the varieties of condition for Routh's array. Okay, thank you.